Good afternoon, everybody. Thank you for joining us. My name is Stacy Mitchell, Director of Communications and Outreach at Viridiant. So I'll be with you all briefly now and at the end, just to give a few housekeeping items. We are going to leave a couple of minutes at the end for a Q&A with our guest speakers, Matt and Nikki. So if you have questions throughout the presentation, feel free to drop those into either the chat function or the questions function, and I'll be back at the end to field those questions to them. I'll also be sending out a survey after the webinar. There will also be an option within the survey for you to submit your AIA member number, which we do need if you would like to receive that one AIA Learning Unit HSW for attending today's training. We will be recording today's training as well, so should you like to look back on the information presented today, you will also have access to that. So I think that's all I have. Again, thank you for joining us, and I will go ahead and turn it over to Viridiant's Technical Director, Matt Waring.
Thank you so much, Stacy, and welcome everyone. I'm really excited to be able to kind of set the stage here for Nikki, and thank you for joining our webinar, Designing HVAC for Health, Efficiency, and Comfort. We're really excited about this one, so Nikki, next there. So I'm Matt Waring. I'm the Technical Director with Viridiant. We facilitate the Earthcraft family of programs, which are programs of South Face, and really kind of touch a lot of different building types. You can keep going there, Nikki. And so we're really excited to be able to put on this webinar in conjunction with our partners. This is Viridiant staff. Quickly, just to introduce you to who we are. We're a small local 501c3 nonprofit here out of Richmond, Virginia. Next slide there, Nikki. Just wanted to make sure that you know our staff. We have some new additions here, Stephen Daring and Emily Bookman. Stephen's our business development manager, and so if you're looking at new business with us, please feel free to reach out to him. His contact information is there for you. He can get you set up and pointed in the right direction for your projects as we move forward here. These are our partners and sponsors, just to hit on those quickly, and obviously Santa Fe is a big one, and we've been working with Nikki and Santa Fe for a long time, and we're very proud to be able to kind of include them in this event here today. But yeah, just wanted to make sure we give a shout out to all of our sponsors and partners there. Keep going, thank you. So right about the time that we saw, right about August, we see a huge increase in just inquiries on moisture related issues, whether it's single family, multifamily, or other. We really were seeing a huge spike through our Dominion Home Energy Audit Program, which we've been providing here through our community energy services. And right about the time we were fielding calls from contractors and homeowners, we also were reaching out and talking to Nikki, and she was fielding the exact same questions as we move into the shoulder months. So we thought this was the best time to really just go ahead and head on address these issues in this format. And so we really hope you can learn something quickly here. Just 30 years of climate data shows us that the Southeast is a very humid place to build and operate buildings. Building is the first component, and operations is the second component that we really need to face up to. And so this is just showing you that really the Southeast representatively is a pretty tough place to build and maintain kind of constant humidity throughout the year. ASHRAE guideline 2014, it talks about ventilation, indoor air quality, and low rise. It really says providing controlled ventilation in hot, humid climates can lead to or exacerbate moisture-related problems in air-conditioned homes if adequate dehumidification is not provided. Right, so right off the rip, I mean that's your major association of heating engineers, right? So, and for whole building ventilation to be effective at lowering indoor humidity, the outdoor ventilation air must have a lower absolute humidity or dew point than indoor air. That's just something we don't have a lot of here in the Southeast. So this topic is super important. You can keep going. We just saw this August increase. You can click next there. But some sweating ducts, lots of infiltration, lots of bypasses into and out of conditioned space over the summer here in some of these homes we're looking at. You can click next there, Nikki. Really bad crawl spaces. We've just been seeing this drastic uptick in these kind of calls, and we've been going out and fielding them as best we can. And again, you can just see how not only exterior drainage affects these situations, but this particular home is over $1 million home with 5 HVAC systems in it and maybe a little under 3,000 square feet. So, this is everything is kind of coming to a head in a situation like this. Go ahead, Nikki. And you can see what it ends up in is really structural damage and deterioration of actual building components. So, again, there's no way to kind of work around this problem of increased ventilation rates and tightening building envelopes. We're just seeing these two things that work really against one another coming to a head, and especially in the Southeast. But I think Nikki would tell you, anywhere the grass is green, we're going to need dehumidification here. So I think that, you know, this is not going away. It's just going to become more prevalent. So okay, we keep going. Nikki, and I think that may be the end of me. So yeah, with that, I'm just going to hand it over to Nikki and try and really just want to set the stage for you and then get out of Nikki's way, because she's a subject matter expert and absolutely a wonderful person, and we're very happy to have her here. So thank you so much, Nikki. I'm going to get out of your way here and be quiet.
Thank you, Matt. I appreciate that. So just to reiterate, this is an AIA approved course. And the learning objectives today, to be able to discuss specific occupant behaviors that are going to result in internal moisture buildup. We're going to look at some green building programs and what their requirements are for moisture control. Be able to identify different scenarios of how maybe air conditioning is not satisfying our dehumidification needs, and then also discuss some different residential ventilation strategies, especially how they apply to the Southeast and the Mid-Atlantic. So a little bit of background, Thermistor is the company, and we have several different brands. Santa Fe is our whole house ventilating and freestanding dehumidifiers. Many of you might know us on the whole house ventilating side as Ultra Air. So we had two residential, light commercial brands. And so what we did is we combined them underneath one, and that's the Santa Fe brand. And then we are made in Madison, Wisconsin. And we also manufacture commercial dehumidification equipment as well. My name is Nikki Kruger, and I am the Director of Marketing and Business Development. I've been with Thermistor for probably 13 years now, focusing solely on residential and light commercial dehumidification. So a couple definitions before we get started. Sensible load is the temperature that you feel when you're in a living space or in an office space. So that's what the thermostat typically is controlling, is what that sensible set point is. The latent load is the moisture load and can be much more challenging to control with a thermostat. Definition, so a pint's a pound the world around. If someone says that you need a pint of dehumidification or a pound of dehumidification, it means the same thing. It takes approximately 1,054 BTUs to remove 1 pint of water. And those BTUs are becoming more and more important the tighter that our homes get, because we might have to think about how we're going to manage possibly some of the heat that's being generated by that dehumidification. And it's really important that we understand that 1 CFM out is 1 CFM in when we're talking about pressures of a home and our ventilation strategies. So the goal of every energy efficient building standard program is to build a tight envelope to reduce the amount of runtime on the HVAC system in order to save energy. And the result is we're manufacturing much more energy efficient HVAC equipment. So we're seeing those higher SEERs. And a lot of these programs give you points towards using higher SEER equipment because it is so energy efficient. But the challenge is that when it's that energy efficient, it typically is not removing as much water as less efficient equipment did. So we're seeing a lot of partial to low load run times on the AC systems because we're making the envelopes much tighter, which means less infiltration from the outside. And then when we hit those temperatures inside these really energy efficient buildings, it takes us longer to drift away from that thermostat set point. So again, we're making our homes and buildings really energy efficient, which is great for less AC, HVAC runtime. But the challenge is if that's what we're counting on to control the moisture, we're starting to see buildings have some issues trying to use just AC as a dehumidification strategy. So I'm not going to go through all the information on these slides, but really this is just to illustrate that in all of these programs, you are going to see some section and reference to dehumidification. So Earthcraft, the Viridiant program, they offer points at the different levels for leaving room for a dedicated dehumidifier, but then also points if you go ahead and put it in at the time of construction. Enterprise Green Communities, again, 7.8, they're going to have something in there about dehumidification and the rationale for that. And a lot of these programs you're going to see, say, either a dedicated dehumidifier or some sort of AC strategy that will allow you to get to a set point, a relative humidity set point. And the challenge with that could be is the AC in almost all cases is going to be overcooling still in order to get to that dehumidification or that relative humidity set point. So Home Innovations, NGBS, Green Certified, they have 7 points. Our MD33, which is now Santa Fe, but the time we had this certificate, it was Ultra Air. That one we actually have green certified because we know a lot of the multifamily projects in the Mid-Atlantic and Southeast might use that NGBS program in order to get their certification for affordable housing. So we do have our dehumidifier green certified as that part of that program. And Indoor Air Plus, if you're doing Energy Star buildings, homes or buildings, they are working on their next version, and this is wording out of that version, and they're actually calling out a dedicated dehumidifier, whole house ventilating as part of that program in climate zones 1 through 4. And I think what we're starting to see a lot of these programs too, as you can see down here, is we're recommending humidity monitoring because you could build it, you can design it, and on paper it looks good, and then we move people in and then all bets are off. So monitoring is really important to try to catch any problems early on. So it's a little bit of thermodynamics for us to really understand how our buildings and homes are working. Is hot goes to cold, wet goes to dry, and high goes to low. So when we start hitting those spring, summer, fall seasons with a lot of high dew points, moisture in the air, that's all trying to make its way into our house. And this high to low is really important when we start talking about ventilation strategies, because again, 1 CFM out means 1 CFM in. And you really don't always know where you're pulling in that warm, wet air and potentially what where it's going to condensate. And so we've dealt a lot with that. I've been on a lot of projects in the Southeast and Mid-Atlantic where we start seeing ductwork getting a lot of condensation and trying to figure out how to fix that. So dew point maps. That's really important in our world. When you're in the world of dehumidification, knowing dew points, because relative humidity is relative to a temperature, and it really doesn't tell you exactly how much moisture is in the air. So when we look at dew point maps, when we start getting above that 55-degree dew point, which is typically going to be in a green grass climate, we're probably going to need some sort of dehumidification for some amount of the year. So, and if we look at our climate zone maps where we see this moist here, that really does fall in line with what we see on the dew point maps. And dew points can be just as high in the Northeast as they are down in the hot, humid South. And even sometimes a little bit more challenging to deal with because not running the air conditioning that we typically would be more in southern markets. But with our building practices advancing so much and our homes and buildings becoming so much tighter, we really are putting a lot of our buildings more into this less AC runtime that we would get up as we move more north. So it's really important to understand that. But when we're bringing in this ventilation air, which high dew point air from the outside, we've got to figure out a way on how we're going to remove the moisture from that air. So sources of moisture, we got construction moisture. Regardless of the type of wood frame construction, we get a lot of moisture that's going to be released into that home or building for the first several years trying to dry out. Seasonal storage effect, this is exactly what Matt was talking about. In the spring, we start getting high humidity levels, high dew points, and we start loading up the inside of the homes with moisture, and everything in that home is absorbing it. Drywall, carpet, mattresses, couches, all of that's absorbing moisture. And then it becomes summertime and it's becoming warmer, so we might be using some air conditioning to start removing some of that moisture. But again, that's at peak times of the day that we're really running for the longer extended period of times. Overnight, probably not as much runtime, but we're still bringing in ventilation air because it's cold or because it's code. And then we get into fall and we're not running AC as much. We still have high dew points. And this is September and October are notorious for where there's actually evidence of moisture loading. Everything has absorbed so much moisture, it can't absorb anymore. And that's when we start seeing microbial growth. And then of course, basements and crawl spaces are always below ground. You can insulate, you can do all kinds of things, waterproofing in order to try to minimize as much of that as possible. But vapor pressure is always working to try to get into those spaces. And so they're very challenging. And then of course we have people. Each person puts out about 1/4 pound of moisture from breathing, and then 1/4 pound for other activities, cooking, showering, cleaning, which we know the last couple of years have been very challenging because so many people are staying home for extended periods of time. A lot more cleaning going on, and so we're seeing a lot more inquiries from people and sales of dehumidifiers because they're realizing now really maybe their indoor air quality and their comfort in their home wasn't quite what they thought it was when they were leaving for 10 hours a day and then coming home. But family of 4 can add about 2 pints or 2 pounds of moisture per hour to the home. And then we have activities like this, you know, trying to dry our clothes, maybe not use the dryer in the home. This is going to add a lot of moisture to the space. Plants add a significant amount of moisture to living spaces as well. So again, we can design, but we never know how people are actually going to live in their spaces. So moisture collection centers, this is pretty common when you actually see evidence, but around the registers, duct work, windows, that's where we start really seeing true evidence of, and usually when it gets to this point, it's going to require a little bit more than just turning on a dehumidifier. We got to figure out why we're having some of these issues potentially as well, and then apply a dehumidifier. So what we see a lot, and this is, you know, whether it's a multifamily or whether it's in a home, there's going to be certain rooms and certain spaces that maybe feel a little bit more uncomfortable than others and may require, you know, dehumidification because they're not getting the sensible heat gain in those areas. And, you know, usually first levels, if we're on slab, because of the amount of moisture in the concrete, we're going to be getting more moisture. So that's typically, you know, if we have a basement, or again, if the house is built on a slab or the building is. So there's going to be certain parts of that building that may need more dehumidification because it's not getting the AC runtime that maybe other parts are. And then construction timing. If we're building through the spring, summer, maybe we close up in the fall, there's been a lot of rain. That's typically when we see that we're going to need some extra dehumidification out of the gate in order to maintain and make sure that we're not starting to see evidence of moisture. So the true cost of moisture, I mean, we've all been hearing it for the last 2 years now. Indoor air quality is a huge concern, and it's not going to go away. It's more and more, and there's a lot of issues, and they're minor ones initially, but they can lead to bigger problems. Comfort complaints is definitely one. Hot and sticky, people keep cranking down that thermostat because they're uncomfortable, and that's their comfort control center, is that thermostat on the wall. So they just keep cranking it down, and pretty soon that can lead to condensation issues, which then can lead to microbial growth. Health problems, we know that there is a ASHRAE safe range of where we need to keep our humidity. We should not be going above 60% during the humid seasons, but for health, it should be at that 50%. So 60% is more of a, to minimize and not allow microbial growth, but really from a respiratory health standpoint, we do not want to go above 50%. Personal belongings can become damaged, property damage, and sustainable issues of the home. So mold remediation, like I mentioned, they're not always bulk water incidences. This is when we do that moisture loading that we can start seeing, evidence of mold growth in a lot of homes. So living spaces need dedicated dehumidification, especially in the Mid-Atlantic and in the Southeast, for comfort, health, and property protection. We're seeing more and more of those partial and no load run times of the year because we're becoming so energy efficient. Can't control human behavior, and it's the only way to ensure 50% relative humidity. And I know from working very closely with Viridiant and their technical advisors that, a lot of times when a dehumidifier is needed, fingers get pointed. They're making us build too tight. That's why we're having these problems. But the reality is our construction practices are evolving to be more energy efficient. We just need to rethink about the systems we're using in those homes and what we're counting on them for. If we need moisture control, we're probably going to need a dedicated dehumidifier because we're not running the AC as much as we used to. So the need for dehumidification is significant. We said health, comfort, all those reasons. There's a lot of organizations out there that have recommended relative humidity maxes. And again, for health reasons, we want to stay around that 50 to minimize the evidence of microbial growth and mold growth. That's 60%, no higher. And that would be in our homes, and that's below the home as well. So if you've got crawl spaces that are vented, we need to think about that strategy. And then once we close them up, I know that, code allows for supply air to condition that space, but the reality is when it comes to a crawl space, all you really care about is controlling that relative humidity, and you can't count on AC runtime for the living space to control the relative humidity in a crawl space. It typically just does not work out that way. So high relative humidity, we can start seeing evidence at these levels. And while, 85% may seem high, where we see a lot of that wood rot and blistering paint is typically if a house is built on a vented crawl space. Usually the walls that are connecting above that crawl space is when we'll start seeing a lot of that blistering paint. And again, wood rot, cupping of wood floors, most wood floor manufacturers, as part of their warranty, have a humidity range that you have to keep it within in order for them to honor the warranty for those wood floors. So dehumidification strategies, we got air conditioning, single stage, variable, we've got mini splits, and a whole house dehumidifier. And we're just going to run through these quick here. So first of all, if we're designing for code, which we should be, we can never design for the thermostat on our manual J's to be less than 75 degrees. And I know that, almost everybody's going to crank it down overnight. We're getting more and more calls of condensation and humidity problems because somebody wants to keep their bedroom at 68 degrees at night, and it's creating cold surfaces and condensation. So what we're designing for is 75 degrees from a temperature standpoint for air conditioning. Now for manual J, we want 75 degrees and 50% relative humidity. And that's what we're going to size our HVAC equipment for, is that 75 degrees and 50% relative humidity. Now, when we're doing our manual J's and we're sizing, that's what we're basing that off of is a peak summertime condition. So that, you know, in a lot of areas could be 93 to 96 degrees, somewhere around there. The reality is typically we hit those conditions for an average of 1% of the year. So we're designing our systems and sizing them based on about 1% of the year, when the reality is we're in those partial load conditions for a lot longer. And that's what can be very challenging. So again, AC is designed to get to a set point. Some of them do have dehumidification or RH set points, but they're going to overcool based on usually about 3 degrees in order to achieve longer run times and more dehumidification. And again, one of the concerns that we have is, you know, where there's a lot of moisture in the air, what about when it's 70 and raining? And that's our shoulder seasons, and those times can last for, you know, potentially a couple weeks at a time. So it can be very challenging to try to control that moisture by using air conditioning. We need about 14 minutes of runtime for the AC coils to load with water and 1 drop of water to start going down the drain. That's average. You're going to get less moisture removal for some of these really efficient inducted mini split systems, because they get to a temperature really quickly. But we need those longer run times in order to actually get water going down the drain. So really about here it's showing that 30 minutes to really get a significant amount of water down the drain. Variable speed, so it slows the air conditioning fan down to remove more moisture, creates a smaller amount of colder air. And the challenge with this is you can create some really cold surfaces by doing that, and that's when we start seeing those rusty registers and condensation. And then the ductless mini splits. Again, they're focusing on a smaller area typically, and they are going to get to that temperature set point very quickly. Less water down the drain. I don't know if you've seen the condensate lines for most ductless mini splits, but I don't have my pen here, but usually, you know, their condensate lines are about the size of a pen. So not a lot of water being removed from them. And their dehumidification mode is basically, again, overcooling based on a timer system. So that variable capacity equipment, I hear it more and more. Oh, I'm using variable speed. It's going to take care of my moisture. And the reality is they don't deliver as cold as air as our older systems did. So they're not removing as much water. Typically higher operational sensible heat ratio, and the heat ratio of the equipment is how effective it is at dehumidifying. And the higher the sensible heat ratio, the less dehumidification it is going to do. And again, a lot of that is because of how energy efficient it is. And no matter what, you still have to have a sensible load. You still have to have a temperature reason for that unit to run. And when it does run, 3,000 of the BTUs is going to, or if you have 3,000 BTUs, 2,000 is still going to sensible and 1,000 is going to latent. So it's not doing more water removal. It's still focusing more on that sensible than it is on the moisture removal. So partial load is really what we need to focus on, because that's where most of our climate zones and our buildings are going to have to deal with, is that not the peak loads, but those partial load times of the year. When we're, you know, between 50 and 80 degrees, and we've got higher than a 65-degree dew point. And this here, my good friend Kimberly Llewellyn at Mitsubishi put this chart together, and it really shows that, you know, depending on where you live, how many hours of the year that you are in these partial load conditions where you're not getting a lot of AC runtime to handle that. Obviously, in Miami, you're going to have more because you don't have much of a winter time there, and they see high humidity levels in the winter time down there as well. So very interesting. But if we look down here in Washington, you know, we've got 2,000 over 2,000 hours of the year that we've got high humidity, and we're in those partial loads conditions. This is a chart that a good friend of mine, actually Mike Barsick at South Face uses and has given us permission to use. I know it's Atlanta, but I think it's, you know, what we're seeing here is if we move even farther up north, that it's probably even more drastic. And what we're looking at is the manual J design condition for Atlanta is 92 degrees. The ASHRAE humidity design load based on the dew points in, you know, that absolute level of humidity in the air is 82 degrees. So we've got a 10-degree difference there on when we have the high temperature and when we have the highest levels of moisture. And then if we take the bin temperatures for Atlanta, you can see that 70 degrees, you know, up to about 90 degrees that, even if we went to 85, 83% of the time, that's where we are at in those conditions. So again, at those partial load conditions for a majority part of the year. So if we go back there quick, so that's the challenge, is how are we going to deal with those partial conditions for a majority part of the year if we're counting on air conditioning. So a dehumidifier really is the best option to help reduce customer complaints and for property and to minimize property damage due to relative humidity. So when the relative humidity is maintained at 55, mold can't grow, it minimizes odors, comfort levels will increase drastically. Indoor air quality is much better. What a lot of people don't realize is that the higher the relative humidity, the more off-gassing of the products that we've used to build the home and the products we put in the home. So formaldehyde, VOCs, all of those increase as relative humidity increases as well. So if we can control that relative humidity, we reduce the amount of off-gassing that is taking place. Finished wood becomes more stable, and then big one is pests are minimized as well. So a whole house ventilating dehumidifier, for those that are not aware, Thermistor underneath the Ultra Air brand actually invented whole house ventilating dehumidifiers in the mid-90s. A gentleman named Ken Gehring invented these. He's, I think, 81 or 82 now. He's on a forum called HVAC Talk. He loves to talk to people about moisture issues, but what's great about Ken is he's going to be the first one to tell you when a dehumidifier isn't going to fix the problem. And there's probably other steps you're going to have to take in order to, before you can add a dehumidifier. And we want them to be successful. So we're definitely known in the industry as experts. We are very heavily involved in building science and making sure that these dehumidifiers are applied correctly as much as possible. So a whole house ventilating dehumidifier hooks up to the HVAC system. And if you want to, you can bring in ventilation air, mechanical ventilation air, in order to meet your ASHRAE 62.2 or maybe whatever standard you're trying to meet. We have a MERV 13 filter in our dehumidifier, so you get really good filtration, not only of the ventilation air, but also of the return air from the home going through the dehumidifier. And then we control the relative humidity in the home separate from the air conditioner. So when the AC runs and it can control the relative humidity, the dehumidifier does not come on. If the AC shuts off or it's shoulder seasons, and that dehumidifier is needed to control to a specific set point, then that's when it will run the most. So, and they're very energy efficient. So this unit right here is one of our smallest one, and it's 5 amps. So very energy efficient at removing moisture. So ventilation is not something that we can get away from. It is here to say we should be doing it. You ventilate because of indoor air quality. It's always going to be an energy penalty, but there's no getting away from it. So we want to be smart about our ventilation. So there are lots of ventilation strategies, exhaust only, which typically uses a bath fan. I will tell you in the Mid-Atlantic and Southeast, whenever exhaust only is applied as the ventilation strategy, those are my first calls for moisture issues and usually microbial growth. When you're exhausting air, you're sucking in from somewhere else. So that'll be my first thing when I go in is, are we using exhaust only? If it's yes, then we need to shut that off and figure out how we're going to address the moisture first that's there, and then figure out a different strategy to be able to meet that ventilation requirement. We've got balanced ventilation. We'll go over a chart here shortly about, ERVs being used in humid climates. They will always contribute to the moisture load, but they do help reduce it. Supply ventilation being pulled in through the HVAC fan can be very challenging as well, because we're not always conditioning that air, and you're using the largest fan in the house to bring in typically a small amount of air. And then a ventilating dehumidifier, and that's going to come through the dehumidifier and then be delivered to the home, and again filtered through that MERV 13 filter. So we've got an app. It's called the Ultra Air Psychrometric Calculator app. And what this does is it allows us to put in the inlet air. You can download this from your app store on Android or iPhone. And the inlet is what the conditions are outside, and the outlet you put in are the conditions I want inside. So typically we're going to put in that 75 degrees, 50% RH, which is the 55-degree dew point that ASHRAE recommends our inside conditions be at. And then the flow is, what's your ventilation rate? So just based on ventilation, this is going to tell me that I need 74 pints of water removal a day in order to maintain 75 and 50% at these incoming conditions. So then you got to take that number and then you got to add in the people. How much moisture are they generating? Family of 4, average how much time they're home. And then you got to figure out if your AC system at these conditions is going to be able to maintain that 75 and 50. So it's a really great resource just for nothing else to figure out dew points, because that's what I always am looking for too. When someone tells me conditions, I want to know what that dew point is. Where am I going to potentially get condensation? And then in this scenario here, we've got 70 and raining. So again, at that 100 CFM or ventilation flow rate, I would need 91 pints of water removal. Basically when it's 70 and raining outside, which are shoulder seasons, that can be for a significant amount of time. So our dehumidifiers are supply ventilation. We try to put a slight positive pressure on the inside of that home, because there's a lot of negative typically going on. We got bats, fans, kitchen hoods, dryers going, that's sucking in. So we're trying to make up a little bit of that air with supply ventilation and put a slight positive pressure to stop some of that infiltration that's coming through. So how much ventilation is possible with one of our dehumidifiers? This is our Ultra Air 98 pint dehumidifier. I think this is about up to a 2,300 square foot house for this dehumidifier, we say, for sizing. And on our website, you'll see on all of our units there, we have 7 different sizes, I think, that you'll be able to see up to a square footage how much we size for typically. We are very conservative in our sizing because it's hard to oversize a dehumidifier, but it's very easy to undersize a dehumidifier. So we try to keep it where 98% of the time we've got you covered no matter what. There's going to be some unusual circumstances where you might need to go even a little bit bigger, but we usually get those calls and help out. But you can get a max ventilation of 1/3 of the total CFM of that dehumidifier. So as you see here, we're going to give you the CFM of the blower's dehumidifier at different static pressures. Typically, as soon as you add ductwork, we're not going to be at 0. I usually just go ahead and assume 0.4. And so the max amount of ventilation that you could get from this dehumidifier set up as it is would be 1/3 of that 215. There are other ways that you might be able to bring in more ventilation air if we use a larger duct and then downsize the return duct to this dehumidifier. But typically set up as is, this is what you would get. So we've got a case study here, and this is really focused on multifamily. And the reality is boxes are pretty much the same, whether it's multifamily or a house. We're trying to build to the same tightness standards, and it requires ventilation for these homes. So this was in climate zone 4. It was constructed in 2015. Now this project used 2-stage cooling equipment to try to remove more moisture from the apartment units. Unfortunately, by using 2-stage, that means they were about 2-ton systems on 700, 800 square foot apartments. So a lot of short cycling was happening, and we weren't getting the dehumidification they needed. So it was constructed in 2015, and by 2017 we had some very obvious mold issues, as you can see here on the walls. And this was late August, early September, again, typically where we start seeing these problems. The resident of the apartment kept lowering the thermostat because she was uncomfortable, and that's all she knew how to do was, that's my comfort control center, so I'm going to keep lowering it. So when we went in, the temperature was 66 degrees and we had 75 almost percent RH in these apartments. And in this building, within about a week, there was 5 to 6 apartments that all showed the same microbial growth. So what we did is we went in and we put in one of our in-wall dehumidifiers into this unit. And basically what you can see here is the dotted line, and I know it's kind of hard to read, but the dotted lines are the outside conditions, and then the solid line is the indoor conditions. So here we have the inside RH kept at 50%, and we've got raining going on outside. So this really stops that we're not concerned about outside anymore. We're just going to be concerned about controlling that relative humidity inside. So very effective at treating the smaller spaces with our in-wall dehumidifier. And that's what this looked like. They have laundry rooms there behind that door. So we were able to put that in-wall dehumidifier right there in the kitchen living area. Had to talk to the residents about, keeping their doors open to the bedrooms as much as possible. And then we have a cover that actually will go over the back of that dehumidifier, but we were able to tie into the drain for the washing machine. So I mentioned earlier about ERVs. This is a case study we did in a spray foam home, actually. And you can get very tight homes with just, without using spray foam, but this one was spray foam. And over here you can see we have partial load conditions with the ERV, and the RH in the living space, this blue line, is basically following the dew points outside. So we're reducing the amount of moisture we're bringing in, but an ERV is still always going to contribute to the moisture load when it is humid, spring, summer, and fall. Over here, we took out the ERV, we put in a ventilating dehumidifier, and we don't care what the dew points are outside. We're just going to set that RH controller to a specific number and let the dehumidifier take care of the moisture in the house. So there was a study done by Armin Rudd with the DOE that basically stated the ERV is ineffective in keeping indoor RH down during floating hours. So that's going to be your shoulder seasons, maybe overnight, mornings. So when you're not in kind of those peak loads, when there's the difference between the indoor and outdoor absolute humidity is small. So when we're running our air conditionings inside for extended periods, we're drying. And then, you know, we've got the humid air outside. So we're getting more of a latent exchange in that ERV. But when it's humid inside and humid outside, we're not going to get much of an exchange in that ERV core. So we do offer a full range of dehumidifiers. We actually have another size up. It's a 205. That one I see used in a lot of light commercial applications, and also potentially if we're treating like common areas or community buildings, that bigger one we might use. But these are our full line. We use these, even that ducted unit we have in a lot of multifamilies, apartments as well. You will always get better control from a ducted dehumidifier than you will from an in-wall dehumidifier. But a lot of times with those sizes of those mechanical closets, we just can't put in a ducted dehumidifier. So, and then we also offer several of these sizes in our standalone units that would go into basement and crawl spaces as well. But these are the ducted units. So our recommended install is to do a dedicated return to the dehumidifier. And then you can bring in this outdoor air, ventilation air. Now, if you have another ventilation strategy and you don't want to use the dehumidifier, you can just cap this off and then you don't have to use it. And then we tie into the supply of the HVAC system. This is really probably the most energy efficient way to install a dehumidifier. Because what we can do here is not run the dehumidifier or the fan on the air handler when the dehumidifier is running, in order to supply that dehumidified air to the entire home. So we have a fan in the unit and it can do that. This is what a 98 pint unit looks like installed. We've got our fresh air or outdoor air coming in here. This is the return air from the house. A MERV 13 filter here. We've got our condensate line here that's tied into the air conditioner or air handler condensate line. And then this is going to tie into the supply of the HVAC system. I know a lot of common installs that we see out there is the return to return install. You will find it in our manuals, and it's typically not one that we recommend if at all possible. There's a lot of challenges to setting this one up to making it work effectively. And so the reason for that it's not on the top of our list, it would be at the bottom of our list as an install, is Florida Solar Energy did a study that basically the research showed it's the most ineffective and inefficient way to run a dehumidifier or to install one. And that's because a dehumidifier generates some heat. So that heat then, if you put it on the return side of the AC, is going to heat those coils on the AC system, which means less water removal from your AC. We want that AC sized and set up to remove as much water as possible when it's running. We are supplemental dehumidification. So we're going to count on that AC to remove some of that moisture for sure. So we want to set that up correctly. And the other thing is, you know, when it generates that heat, there's usually water on, and it's drier air that the dehumidifier produces. That water on those coils, when the AC shuts off, will be re-evaporated when the dehumidifier comes on back into the living space. And it can actually increase the relative humidity by 10%. So everything you just tried to achieve basically did not go down the drain. It's not working. It's going to rehumidify. And I get calls from contractors saying, I put in a dehumidifier, you know, 2 weeks ago and the RH has gone up in the house. And so they think it's something wrong with the dehumidifier. And as soon as we have them go in and we figure out they installed it return to return, and we have them go back out and do a dedicated return to supply, then it usually fixes the problem. So Dehumidifiers, if we look at it from an energy standpoint, an AC removes 2 to 3 pints per water per ton. And a dehumidifier is 5 to 9 pints of water. So when you look at what you're getting for water removal with the same amount of energy, a dehumidifier is far more energy efficient and effective. And each degree you set the temperature lower, you use your AC energy use goes up by 12%. So when we control the relative humidity, we usually will feel more comfortable at a higher temperature. So I guess if you look at, when people are in Phoenix, Arizona, and they're like, yeah, it's 100 degrees out, but it's still pretty comfortable. And if you go down to Florida and everybody's like, oh, it's 100 degrees and that humidity is so high and it's miserable, it's not the heat, it's the humidity. It's the same thing. If we can reduce the relative humidity and the moisture in our living spaces, we can increase that thermostat setting 2 to 3 degrees and be just as comfortable. So it really is an energy saving strategy as well by using a dehumidifier to control that moisture. And there's a resource out there called Red Calc Residential Energy Dynamics. You can go in, put in the watts of our dehumidifier. This is a in-wall, how many days of the year it's going to be in use, how many hours of the day you're going to use it, and how many minutes of each hour. And then you put in your kilowatt right there, and it'll tell you basically how much energy that dehumidifier is going to use. And I did this also for our 98 pint dehumidifier. So you can see really how energy effective it is to use a dehumidifier to control that moisture. So key takeaways. Houses are becoming tighter and requiring less sensible conditioning, yet latent loads are the same or possibly increasing. There must be a sensible load in order to remove humidity with an air conditioner. So if you're counting on air conditioning, that means that there's got to be a temperature load for it to run. Houses work until you put people in them. You can't control how they're going to run that HVAC system. Senior housing can be very challenging. We've worked with Viridiant on a lot of those, and people like to, in those situations, like to keep the thermostat at 80 degrees, and you're just not going to get any moisture removal. Commercial grade dehumidifiers reduce home warranty claims that are usually associated with high humidity. And people want homes that are safe, healthy, durable, comfortable, and energy efficient all the time. And that's a wrap. Are you with me still, Matt?
Absolutely, absolutely. I was wrapped the entire time, Nikki. It was great. Thank you so much.
Well, it was a lot of information, but again, this is being recorded, and hoping people can go back and look at it, and then email us any questions that we might not get today, but they think of later.
Absolutely, that.
Yeah.
And one thing you said just quickly, and I know since you probably have some questions, one thing you said that I thought really kind of rung my bell was just like how we do want to provide conditioned air to these crawl spaces, but that's a pressurization strategy. It's not a dehumidification strategy for those.
Exactly.
Very closely intact with grade, lots of moisture coming out of the ground all the time. Like that's a great way to think about kind of conditioned, enclosed, encapsulated crawls, whatever vocab you want to use there. But I thought that was great. A really interesting thing. Yeah. So Stacey, do we get any questions there? Oh, and Nikki, sorry, do you want to add anything to that?
I was just going to say, and when we look at crawl spaces, they're usually out of sight and out of mind, but 50% of the air below the home makes its way into the living space. Right. So we do need to be concerned about the humidity and everything else that might be in that air that's making its way up.
So important. Yeah, we get a basement for short people, right?
Yep.
We want it to be almost living space, just very, very, very short living space.
Absolutely.
Awesome. Well, thank you, Nikki. That was a great presentation. We do have a couple of questions teed up. We'll try to get to as many as we can to be respectful of folks' time while you're likely on your lunch break with us this afternoon. So first question, here we go. A properly sized and ducted dehumidifier can also provide the fresh air ventilation and remove the need for an ERV.
Is that a question?
Yeah,
yes.
Yeah, I think it's it's a statement, but I think Nikki
yes,
jump in there, but I think
Absolutely. So, and it can be challenging because I know a lot of programs potentially, depending on what green building program you're building to, might require balanced ventilation. But the reality is, and if you use an ERV, a lot of these ERVs now you can set to positive pressure, but our dehumidifiers can provide that positive pressure ventilation, plus MERV 13 filtration, plus you get dedicated dehumidification for the entire home. So if you have to do one or the other, I don't know if anybody on here knows Matt Reisinger, who's got his YouTube channel down there in Austin. I know he's grown a lot, but he'll use an ERV and a dehumidifier and just have the dehumidifier focus on the dehumidification. But he always tells people, if you have to choose one or the other, always go with the ventilating dehumidifier to control that moisture and provide that ventilation air.
Yeah, he's down there in Austin where it is very humid. That's right.
Yeah, and again, anywhere in those green grass climates, moisture is going to be something to deal with, and you can't count on the AC.
That's right. That's right.
Can you discuss integrating ERV and dehumidification for something like passive house?
Absolutely. So I'm not going to get into that here because my colleague David Treelevin wrote an article on Green Building Advisor on how to, I think there's 4 different options of integrating ERVs and dehumidifiers together and the pros and cons of each one. You know, he is going to start out saying keeping them separate is probably the best thing. And the reason is the challenge is they both have fans. So we're going to be dealing with static pressures and competing fans. But he does give different options on how to do it on there. And again, the pros and cons of each one. So if you go on greenbuildingadvisor.com and put in ERV, I think it's one of the first ones that pops up.
Awesome. I'm going to check that out for sure.
So the next question is more in the form of a comment. So maybe if you can elaborate on what this comment says. I didn't see an exhaust air path for air exiting the home for the HVAC integrated whole home setup.
Yep. So we are a positive pressure ventilation strategy, so more of a supply. So there's enough negative going on in the home that we're not trying to achieve balance. We're trying to put a slight positive pressure on the inside of the home to minimize the infiltration from the pressures outside. So that hot trying to get to cold, the wet trying to get to dry. So, you know, a bath fan, your kitchen hoods, your dryers are typically going to put you underneath, you know, negative. Hopefully they don't all 3 run at the same time, but that's going to be negative. We're going to try to do that slight positive pressure with our ventilation strategy, which building science community recommends in humid climates.
Absolutely.
All right, next question. Are there specific orientations, especially related to multifamily units, that may be in more need of dehumidification?
Yes, so usually first floor units, we recommend installing dehumidifiers and all those out of the gate. There's just not enough heat gain in those units in order to get enough AC runtime. And then after that, the interior units, usually, because we see this in townhouses all the time too, that the interior units, again, don't get enough AC runtime. And then monitor. So, you know, if you can't put a dehumidifier in every unit, then those are the areas that we highly recommend, and then monitor the others. Because again, how people live in these is going to affect the need for additional moisture control just as much as orientation and ventilation. If they're not running the AC, you're not getting anything. If they've got a lot of people in there, if they have pots boiling all day cooking, all those things are really going to affect, and you just can't design for those out of the gate.
Right. Yeah, that makes total sense. Slabs are curing all year, like for the first few years. I mean, the whole deal. North facing, you know, I know in our building here, which is not a building science, you know, I don't know, it's a 1908 or something row house here in Richmond, but you know, the south side of our building has dramatically higher cooling loads than the north side does. And so, giant stratification just in our one building. So if you think about a north-facing lower floor multifamily unit, the cooling load on that unit versus the worst case unit that they size the cooling to could be dramatically different. And then also, interior sandwich, one exterior facing wall. Yeah, very cool.
Well, thank you both. We are at 1 o'clock here. So Nikki, thank you so much for joining us for this conversation today. And just as a final reminder to everyone, this training is worth 1 AIA Learning Unit HSW. So if you would like to redeem that credit, make sure you'll be getting an email from me, Stacy Mitchell at Viridiant. That's a real brief survey, and one of the questions in there asks you to provide your AIA member number, which we will have to be able to process those credits for you. The session is also going to be recorded, or it is recorded. It would be a little bit late now if I hadn't recorded it. So I will be sure to post and share that link as well in my follow-up. So it'll probably be a little bit later this afternoon that I'll send that email so that I can be sure to share this link once I get it up on YouTube, on Viridiant's YouTube channel.
And the certificate and for your AIA credit will be coming from me. So this presentation is approved through Santa Fe. So just in case you're watching from that to come from Stacy, it'll be coming from me once we get those AIA numbers.
Yeah, good thing to note. Thank you, Nikki. So with that, everyone, thank you again for joining us, and we hope to see you at a future training.
Thank you all so much. Nikki, thank you so much.
Yeah, thank you, Nikki.